Imagine me and you, I do. I think about you day and night. It's only right to think about the girl you love and hold her tight.
Welcome to Crazy Carrot Studios. My name is James, and today we will be going over our third-person character, adding in new movement, rotation, a sprint, and a jump button, and then, if we have time, Cinemachine camera system. Back in our project here, if you remember correctly, we got our character, our little ghost, to move around using the controls. Today we're going to change some of those movement codes and show you some more efficient ways of doing so. Now on our current script, you will notice that we have everything working, but we're using a lot of things in update and fixed update, and I'm going to show you a cleaner way of doing this, as that's a little bit more antiquated with the old input system and the other ways we used to do things. But we're going to use Unity's documentation to take this a step further and expand on it. Now in our description I provided a link to Unity's documentation for the character controller.move. You will notice that Unity provides an example of how they do the move system with their character controller component. So let's see how we can merge some of what they have with what we have. Now if you noticed here, we're going to take their variables, everything but the player's speed, because that's going to match our move speed, and put them together. Also, we're going to take over their bool for the grounded player and the player velocity and put them in a private section there. And lastly, we're going to take their character controller and give it a name controller and put it there, kind of right there with our player input. In the next section, where we have our awake, we want to bring in the controller and get the component for it. Now you notice on the documentation they have add component, but we added our component already when we put the required component on the top of our script. Now we're going to make a few other changes. First, we're going to create a few more variables so that we can cache the name of our action assets in the input system. So we're going to paste this in here, and you notice we got some private input actions, one for the movement, jump, and sprint. Now these are coming from that player input system that we created in the last episode. But rather than risk a mistype of some sort, we're going to store our name or the string of that variable into this input action. And we're going to do so by putting that in the awake method by pasting this right here. Now this is going to allow us to cache the movement, rotate, jump, sprint actions into the variables that we created, so we don't have to type those strings each time. Alright, now that we've got everything set up there, let's move on to the enable and disable. Before, when we were passing, all we were doing is enabling the action itself, and then we were actually getting the value in update. A little bit more efficient way would be to pass the value from the enable, so when you hit the controller or the keyboard, it's automatically going to pass that vector2 straight into the update method. So I am going to basically take all this out because we don't need this, and we're going to make this a little bit cleaner for one, and we're going to get away with using the fixed update, so we no longer need that. So we came back up in here. I've got to add that ending bracket. We came back in here for the on enable and on disable. I'm going to paste in a different look. Now, just like before, we're passing that vector2, but we're passing it through the enable perform function. Now, last time we didn't have a jump or a sprinting, so I've added those in here as well. Now you'll notice that they all have a little red squiggly line meaning an error, and that's just because we haven't created the function that this is trying to represent. Now we could come in here and just come down here and say public void jump, and that would basically solve that problem. But an easy way to do this, to solve a lot of this, is come in here to jump and go to quick actions and refactoring by right clicking on it. Then you can go to generate method, and it'll generate that method for you. Same thing with the start and sprinting. We're going to quick action it generate method, and it created that for me. And again for the stop. So quick actions, that again, that's right clicking on it. Quick actions, generate stop method. So now it generated all these methods for us. We didn't have to type it in. That's one of the beautiful things about Visual Studios. So if you look at it like this, this is no different than what we would normally have when we create our own functions. Now I'm going to reorder these just a little bit, just because I typically like to have a start going before a stop, and it just makes a little more sense. But it really doesn't matter because it's only going to fire off when you're telling it to fire it. But just for my own OCD, we're going to set that up like this. Now let me explain a little bit about what exactly the CTX and the lambda expression, which is what this is actually doing. I'm going to show you another little trick with this. When you hit 3 spaces, it gives you a summary that allows you to put a bunch of comments in a row without having to redo the hashtags on each one. Now I took the time to write this out so you could understand what these are doing. In summary, the CTX parameter stands for context. It's an argument provided by the Unity Engine.input system package that's used to handle input actions. In this particular case, the CTX parameter is used in a lambda expression, which is what this is right here, to define what should happen when the movement action input action is performed. The CTX.readValueVector2 method is called to read the value of the input action, which is then assigned to the move input. So what that's saying is it's going to assign the value of the vector2. So that's going to be the controller's directions when it gets an input from the controller or keypad. It's going to pass that vector2 to this variable right here. Lambda expressions are often used in C# to define a small piece of functionality that can be passed as an argument to a method or assigned to a delegate. They are concise, expressive, and often provide a more elegant way of defining functionality than writing a separate method. So this is just, like I said, it's a more optimized way of doing it than adding a whole different method to do the same thing, which is what we were trying to do before. Now, by doing that, we're going to pass in, and everything is going to go off this move input. So when we pass in the vector3, it's going to be the move input.x, the move input.y, and we'll show that as we go into it. But I wanted to get you a little bit better understanding of what exactly we were doing. Now, going back to our Unity documentation, they had a update function that included the grounded for the jump and so forth. Let's go ahead and copy that and bring it into our script. So we're going to come over here, and right underneath the disable, we're going to create the function for update. We're just going to paste it in there. Now, there's a few squiggly lines, mainly because ours has the underscore before it. So we actually have these variables in there. We just got to go back and assign the... I messed all that up. There we go. Make sure we get the underscore before it. Same thing with the other ones. Now we don't have a player speed, we have a move speed. So we want to make sure we change that to be what we have. Or you can keep it as player speed and change the one above. It doesn't really matter. Okay. Now here, you'll notice it says get input down. That's the old way of the old input doing it. We're going to completely take this part out for right this moment. And then again, we're going to go ahead and make sure these have the underscore in front of them. And that gets rid of all our error. Whoa. There, that gets rid of all of our errors. Now, we also have the old input system here for the vector 3 move. We want to go ahead and remove that, and we're going to go ahead and place in the one we're going to be using. Now, we also need to make sure that this matches. So, controller.move, we're moving in the move direction. So, let's go ahead and put that in there. And that's only because Unity's documentation had it set up a different way. We're using move direction as our variable. And as you notice, the move direction right here is exactly what we used in the last one. So that has not changed. We're just moving it over to this one here. Now this part here, because of the new input system, we don't need that. We're already passing in exactly what we need through the character controller. Okay, now that we have the ability to move, let's go ahead and give us the ability to sprint. So let's go ahead and add in here a sprint multiplier, which is going to be a private float, which we're going to value a 2f. Let's also do the same here, because in the documentation, they have it set at 2. So let's do the same. And then we're going to do the sprint multiplier, where we can multiply the move speed by the sprint multiplier to give it a faster speed. So we're going to do that down here right under our move section. If is sprinting, move direction times equals sprint multiplier. Now, we have an error here, and that's because I forgot to put the variable for the bool sprinting. So what we need to do is come back up here, and we're going to do another private bool, and we're going to call this sprinting equals false. Oh, I can't spell. Just like that. Now that's going to take care of that error right there. So now if sprinting is true, we're going to multiply the move direction by the sprint multiplier. So what we need to do is in our start sprinting, we need to set it to true. And in the stop, we need to set it to false. So let's do that right here. Oh, wrong one. Right here in the start. Sprinting is equal to true. And this one's going to be equal to false. Just like so. So now you hit the left shift button or the bumper button that we had on the gamepad that we assigned earlier in the last episode. It's going to fire off this function here and tell us the sprinting is true. And during the update, which happens every frame, if sprinting is true, it's going to multiply the speed. If it's not, it'll ignore this completely. So if sprinting is not true, which is false, that means you let go of the shift key or you let go of the bumper, then now this is false, so it's no longer a true and it's just ignored altogether. Lastly, we're going to come back to our documentation from Unity here, and you're going to notice here when we had the original jump function, now granted this is using the old input system, but it's calling and making a player velocity plus equals mathf jump height minus 3 times gravity value. Now we need to place that in here into our script. So let's go back in here to our script that we've got going on here, and we are going to do something very similar to that. Let's paste this in right here. Now, if you come back up here where we have the jump action performed, well, that's when you press the button to jump. Now, that's going to allow us to go here, and if the player is grounded, it's going to allow you to jump. Now, in the Unity documentation, it had if input plus if grounded. Well, we don't need to do that because we're already doing that from the original jump function in the beginning. So as long as the player is grounded, we can jump. Now, I'm no physics expert, so I took the time to make sure I found the proper explanation to explain what this is exactly doing. So player velocity, that whole line right here, basically is the code for making the player character jump. The calculations in the right-hand side of the assignment involves the jump height, gravity value, and a constant of minus 3.0. The gravity value is the acceleration due to the gravity and the negative value that makes the character go up. The jump height determines the height the player can reach during the jump. The square root of the product of these three values gives the initial upward velocity required for the character to reach the desired jump height. This formula comes from the kinematic equation for vertical motion. The result of the calculation is added to the y component of the player's velocity, which will then cause the character to move upwards. The y component of the velocity is affected by gravity, which will gradually decrease the upward velocity and cause the character to fall back to the ground. I hope that gives you a little bit better understanding exactly what this is and what the math F square is doing for you. Now let's go ahead and make sure we save everything, and let's come back into Unity. Now, when you get the player controller put in here, when you re-add it, it should automatically add a character controller. Now, for this character controller, you need to do a couple of things to get it set up. One, if you don't have it set, hit Gizmo up here so that you can see the outline of the collider. And you want to set your collider center to 0.5, 0.2, and height 1. And what that is, if you look at this drag, this part here is basically telling it how wide around the character you want the collider to be. The height is how tall the character is, which is 1 unit. And the center of it, obviously if it's a 1 unit, the center is going to be 0.5. If we were to move this, you'll notice that it's moving up and down that collider. So you want to keep it right there in the center. And this way, that collider is what's actually affecting the ground. When you do a movement, you could deselect everything, and the collider is what's actually moving. And everything else is kind of standing still within the collider. So the collider is what you really need to make sure is set up correctly. Now, if you have it down too far, it's going to interfere with the ground right off the bat, and you're going to have some messed up animations. The other thing you want to make sure you set up is the minimum move distance will probably come in at a 0.0001 or something like that. Set it to 0. That way, when you're doing your jump, you're not going to have any issues. Typically, when you set that minimum move distance, that's saying if it's not moving anymore, so if it's less than or equal to 0, then you're able to jump. If you had it at 0.001, it might be still technically moving, and you might not be able to jump at that moment. So it's good just to keep that at 0 when you're doing something like this. Let's go ahead and press play and see how this works. Now that we have it all set up, you notice our character is still moving. I'm going to turn off my gizmo so I can see it all clearly. And it's still moving the way we wanted it to. It's jumping. Look, good it go. And then if you notice with the speed, if I hit shift, it doesn't look like it's moving too much faster. Let's see what's going on with that. So let's go back into our script, see where we went wrong with that. And I can see it right off the bat. In my move section here, I'm calling the move function before I check the speed. So I need to cut that and move it down below the speed variable. And that way it knows whether it's running or walking based on that. So it needs to check the sprinting and the multiplier before the controller moves. So it is relevant on where it is placed because it's going to fire off in the order that you place it in. So let's save that and try this one more time. Okay, let's go back to the original settings and hit play. All right, it's moving really slow. It is moving faster. So let's adjust this so we can see a little clearer. We'll make the walk 2, and we'll make the sprint multiplier 5. Should see a big difference there. All right, you see it's moving around. Now a sprint definitely moves faster. And we can jump. We can, whoa. There we go. So now you see how that works. We will try to add the camera system to it next. I was hoping we'd have a little more time today, but on our next episode we'll actually add a Cinemachine camera so that it will follow the player wherever you go. And from all of us at Crazy Carrot Studios, we would like to say thank you. And don't forget to please like and subscribe. We will see you next time when we get back to Learning with Bob.
The sky.